have to say I think he's absolutely probably one of the smartest people I've ever met in my life. Has a very diverse background. We're going to talk about things like working in nuclear engineering in the Navy, software engineering, electric motorcycles, and troubleshooting. He's like a troubleshooting genius and has some great tips on how to troubleshoot. Because how many of you are going to have to troubleshoot your project? Actually, every hand. There's not a hand that should be down. Right. So we're going to turn it on over to Brian, who's going to tell us some awesome things about what he's done with his life and the things that he knows. Feel free to ask me questions. Jump in. Let's make it a discussion.
Thank you.
Wow.
Nice to meet you all. This is a really cool lab. I'm glad you guys have this. Yeah, I'm Brian Rice. I've done a lot of things in my life. I've kind of had to wander around to find my way. So this is my electric motorbike, which is parked outside, and I like using it because, for one thing, people aren't aware electric motorcycles exist, and I like the idea that even with EVs, people could grapple and fix their own car, kind of thing. So I've been using this as like a little bit of a kind of a vehicle I can tinker with, but also I use it to like educate people. I showed this off at Maker Faire for a bit. Right here is one of my favorite recent shots because that's the bike they sell you, which is really nice looking and small and tight and very, very composed. And this is mine, which has like hardware hanging off of it. It's got extra chargers I bolted on, and I'm running cables everywhere. It is safe for me, that kind of thing. It's got like a programmable reverse mode. I had to learn how to program a motor controller to do that. And unlike a lot of electronic projects people start out with, if you're doing like 12-volt systems, these voltages and currents are a little more dangerous, so you have to kind of approach it gingerly. One thing I do that sort of came out of me meeting lots of engineers, I'm kind of working backwards here. I maintain something called the unofficial Zero Service Manual, which is, it's just a MediaWiki instance where we coordinate all the information.
What is Zero?
Zero makes electric motorcycles.
Oh.
Yeah. So they're the biggest seller of electric motorcycles, although you probably have not heard of them. Has anybody heard of them? Yeah, they're in Scotts Valley. They're like 70 miles away, and they don't really register with most people. People know about Tesla. They know about all the major car manufacturers.
So you own this Wikipedia page? You moderate it?
Yeah.
Wow, guys, you guys are meeting someone famous.
It is actually weird. The first time I realized it had turned into something. A bunch of people came in from out of town for an electric motorcycle meetup, and everybody was like, "Brian's here. We should ask him questions." And I'm like, "Oh God, I just wrote a page on the internet. What happened?" And let me rewind. So how did I get here? I went to high school and was a math and science geek like you guys. That was a long time ago, mid-90s, and back then I was interested in aerospace and mechanical engineering. I love aircraft, I love vehicles, and I wanted to figure out what I could do about that. Computers and CAD and so forth were starting to become really accessible, so I was getting into AutoCAD and Mathematica and stuff like that. And when I got to college, I was like helping run a lab, like helping people work through their engineering problems, like they're, writing down equations, and they're trying to figure out, like, if I build this structure, is it going to collapse, or can I tell how hot this circuit board is going to get? For various reasons, I dropped out, and I think this sort of says, like, I wander around a bit. I decided to join the Navy. There's a nuclear program that's sort of foundational to the nuclear power sort of industry. They run them on submarines, so there's very compact nuclear reactors, whole systems that run inside of submarines with a very small crew. And then there's really big power plants that they run on aircraft carriers that are just as big as land-based power plants. And these enable these submarines or aircraft carriers to go around the world multiple times without like refueling. You don't have to carry a lot of gas. At least on an aircraft carrier, yes, they have gas, but they keep it for the aircraft. And they put you through about 2 years worth of school, and they kind of help you become a professional when you think about having a 19-year-old running a nuclear power plant could be scary, both for the 19-year-old and for everybody working around them who has to depend on this nuclear power plant to be smooth and trouble-free. Let's see, I'll give you a little bit of illustration. A lot of what I work with in the Navy is not something I can share, so I'm just picking some public domain photographs. Often enough, you're looking at control panels like this, which will have like dials everywhere, arrows running in between things, panels of lights. They're very encoded. They have like weird acronyms and abbreviations, and a lot of it is like steam that's running through pipes, steam that can kill people, but is generally meant to actually like push the turbines and get the ship through the water. And then there's the electricity, which might be 4,000 volt electricity running through cables about the size like the size of your hand in width, and they just run everywhere. And you have to figure out, how do I route the power around so that I can run things smoothly? How do you think about redundancy? And some of it, some of what they teach you is troubleshooting and also communication. And I think this has been really rewarding for me, even though I don't do, I'm not a nuclear technician anymore. It's been really rewarding for me in the field of software, because these skills aren't necessarily taught as well in the field of software. We know how to debug, and we do know how to go through processes, but there's like a certain type of set of skills that help you get a higher level picture sometimes, or learn how to tell somebody on the other side of a conversation. You could say like, oh, I'm your API user, and when I increase my rate of calling your API, it breaks down in this way. How do you present that so that they understand and appreciate what they can do? So let's see, some of the strange things that go on in the Navy that maybe illustrate some things is like, even though I was in the military, I worked for the Department of Energy. So it's a different branch of government. So even though you're defending the United States, you're also like managing nuclear materials for the federal government. There's like a totally different mindset around that. You get paid better. That was nice. And then they have these dual and opposing tensions. There's this thing they teach you where there's a lot of teaching and a lot of classes and a lot of test taking, and you might fail out because of the test taking. But often enough, people fail out because they might say, your instructor who's constantly quizzing you, constantly like maybe takes you around a power plant and says, "What does that valve do?" And you're like, "I've never seen that valve." And then he asks, well, can you figure out what it does? And if you kind of BS it, if you say like, I looked at something, I checked it, and it was working fine when I last looked, and they said, well, it went on fire before you ever saw it, they're going to be pretty upset with you. And that's the thing. You have to kind of like, you have to have like a kind of an honorable or an honesty to a fault type of thing. You could say, you know what, I have to admit I didn't look. On the flip side, if you're in an emergency, or even not in an emergency, and someone gives you an order, in the military you're supposed to follow orders. That's like right at the top of the philosophy of the whole thing. It's a hierarchy, it's chain of command, all that stuff. In the nuclear Navy, there are certain circumstances, and you have to know this. You have to always be aware of this. You can say no. You can not only say no, but you have to follow it up with like, I think you're wrong. I think we're in this situation instead, and because of that, we have to do this. Or I think you've misspoken. I think you meant to say blah. And the difference between that and that often might be like, I turned something off that was supposed to be on, or vice versa, and I might break something. So this gets into actually one of the very few situations I've been in where something bad happened. How many people think nuclear power is exciting? Wow. Well, I'll disabuse you of that. It's very boring, because what you do is you look at this all day and all night, and you talk to each other. You just talk. and there's a lot of paperwork, and the thing is, don't get me wrong, this is actually exciting, it's just that mostly nothing should happen. If something's happening, you spend a lot of time making sure, like, well, the dial just moved. Do I know why it moved? Is that a good thing or a bad thing? There's a documentary going around about Chernobyl right now, and Chernobyl is a particular type of mess that it's very hard to. It's a lot of complicated thoughts I have about that. But a lot of it did come out to, like, they were looking at indications like this, and something really dreadful was about to happen, and they didn't know, and they couldn't figure it out. And that's the thing. It's like you have to turn a boring situation into something that you can kind of work through and avoid injuring people, killing people. Who knows? You don't want to think about that. But the one situation I was in that was actually kind of scary was we were doing some routine maintenance, and I worked as an electrician, so I worked with the giant generators. We're talking about generators that run like higher than this ceiling, and they're big cylinders, and they have steam plants running one side of it to turn the generator, and then electricity is coming out the other side. And in this case, we were doing this regular exercise where we would turn off one of the generators. We would take all the load off of it. We'd put it on another generator. Say like, okay, all this part of the aircraft carrier is going to run on this generator, and then we're going to turn off this one, and we're going to spin it down, and we're going to do maintenance on it. We're going to like change the oil. We're going to check some bearings. We're going to look at various electrical connections, and we'll do this overnight when no one really depending on this. And there's another practice out of the nuclear Navy where I was in a role where I was meant to observe the person doing the work. So often enough, there's like this practice where you say things like, I'm going to go do some procedure. I'm going to go through something and I know what I'm doing, but it will help if someone is there to kind of like watch me do it, listen to me say what I'm going to do. And we'd even do this thing where you point at a switch before you turn it, and you say, I'm going to turn this switch to on because we're going to do this next, and this is the right thing, so to speak. And you'd wait for the other person to go, yeah, that's the right thing, and then you would do it. And in this case, we were going through the exercise of taking the generator down, and at some point they said, yes, and now I'm going to turn down the exciter dial on the generator because we're about to turn it off completely. And they pointed at the switch, and they turned it, and they didn't give me a chance to check. And it turned out they had turned down the generator that was online, and they basically turned on a giant, I don't know how to put it this better, it was basically a giant dimmer switch on half of an aircraft carrier. And you saw all the lights, or half of the lights in the room, go brown. And you heard things change in the plant. You heard this like, roar, 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 like that. And that's the moment. That's when you have this moment where you realize things are no longer boring. And I really can't fix it now. And I have to say aloud, I think we've just browned out half of the aircraft carrier. And I think the best thing we can do is turn, and I said this in like way faster than I'm doing this now. I don't even know what I said. I just know that everybody said, yeah, I think we have to do that. And we turned off half the aircraft carrier while we then, switched everything out, and then we had to like turn everything back on in stages because we didn't know what we had damaged. And I spent all night running a diesel generator just as a backup because that's just what you have to do. It's a long and complicated thing. But yeah, the event happened at like 2 a.m. when everybody's tired, by the way. Everybody has been doing their job all day, and we hoped we were going to go to sleep at 3. And no, I went to sleep at 5. And I think like $500,000 worth of damage was done. There's a little bit of like, oh, military prices are a little higher than normal. Actually, way higher. But if I had to summarize all that, what I really got out of it is encapsulated on a website that somebody else made. This is really amazing. It's called the Art Troubleshooting. It works with, it's not about electronics, it's not about mechanical issues, it's about how do you break down a problem. And I love this. It's got like a little one-page sheet, here are the virtues you can kind of hold. And it's like, be skeptical, use your senses. You know, it's a little bit more like organized, systematic, stuff like that. A lot of these big questions are like, when you're troubleshooting, you think about, well, what's changed? Like, I have a result that's changed, like suddenly this thing broke. It's like, well, what changed since the last time when it did work? And troubleshooting sometimes means you change how you do your work. If you expect things to break down, you start to work differently after a while, where you say like, I'm going to change exactly one thing and then I'm going to retest. And I might like make it really fast to retest. I want to like make sure the LED comes on. I want to hit the button and have the motor turn a wheel. You try to make whatever you're doing into this really fast loop where you have like something that's not dangerous at all, that you can just quickly like hit the button and check, and then you make your adjustment again, and then you check it again. And the idea is that by tightening the feedback loop, you can avoid getting yourself lost. So for example, if I made 10 changes, and I was in the flow, right? I'm sitting there like, oh yeah, I'm going to rewire this to here, and then I'm going to do this with this, and then this, and I forget. And I'm like, I forget maybe everything that I've done, but you don't think about it because you think, oh, it's going to work fine. And then you hit the button and nothing works, right? Or maybe you have the puff of smoke come out, or a spark hits, or something like that. And then you're in trouble because, I mean, yeah, you can do it, but there's good 10 changes. You don't know if it was change number 1 or change number 7, and you don't even know whether it might be a combination of the changes. Maybe change 2 worked great, but because you did change 2 and change 8, whatever. I don't know how to get more particular.
Does this sound familiar to any of you guys?
Yeah, the thing is, this is going to continue. Like, I work in software and I troubleshoot things every day where it's like, oh, someone like changed DNS in this one thing, so the name that the server knows to look up the other name, the other server by, isn't quite right. And it's only not quite right in these circumstances. And if you don't have like a mindset like this to kind of like work backwards and have a change record, so you can quickly say, oh, here's a quick list of like what's worth checking. Then yeah, you can get frustrated. You know, you can waste a lot of time. You feel dumb. You shouldn't feel dumb, but I'm just gonna be honest. I feel dumb most of the time. And yet, it's good to get around that. It's good to appreciate the fact that like, it's not about being dumb or smart. Sometimes it's just a matter of can you help yourself so that you can hold the problem in your head at all times, so it's easy to remember everything that you might want to do, and so you know how to back out of situations. Because not having that feeling that you can just get back to a normal thing, that's what makes people feel really anxious, and that's when sometimes you make secondary mistakes. You start like saying like, oh no, I gotta fix it, I'm gonna do this and that, and then you get yourself even more lost. And that's a tricky thing. I can talk about the electric motorcycling problems that I have. So I've got a custom bike. I can travel on an electric motorcycle. I plug in at campgrounds and I plug in at EV stations. And I have a little onboard controller. It's not a Raspberry Pi. It's the BeagleBone. And it's got custom code on there. Somebody sold it to me. It's got some wires that run everywhere. It runs a protocol called CAN. Which is common in vehicles, but you know, doesn't make a whole lot of sense outside of that. You know, it's not like Ethernet. Sometimes on the road, like nothing turns on, and it's not on fire. It's nothing, nothing dangerous, but you know, your battery isn't charging, and you don't know why, and you have to go work backwards. You're like, oh, did I remember it? Is the bike on? Is the contactor shut? It's like an internal circuit breaker. How do I know that? Because the bike maybe doesn't tell you very well. Sometimes you see, oh, the dash tells me X, but you're acting like that's not true. And you're like, well, how do I know if the bike is telling me a good thing? Like, I know it's not lying to me, but it might be mistaken. And you don't want to like distrust your equipment, but you do have to know that when something doesn't work, it might not work in so many different ways that you have to sort through. And that's why I love stuff like this. Because being able to approach a problem in a systematic way can be really at least reassuring and very helpful when you might find yourself what you think is in trouble, right? You're stuck roadside. Like I've been stuck roadside where I eventually, like one time, I actually had to get a tow. But mostly it was one of those like, oh, I see. If I rewire like this, I can get it going and I can get home, and then I can go take it home, and then I can go figure out what really went wrong. At the moment, I just need to get it. And then outside of that, like by day, you know, I work on things like Tableau. That's actually one of my favorite things. Tableau has a great ethos, help people see and understand data. And for me, this spoke back to like how engineers were trying to like run their simulations and trying to figure out, is this going to work? This is more generic, of course. This is just generic business. In this case, it's just a bunch of survey answers for electric motorcycles. But yeah, like one of the nice things about this tool that I managed to put in here and sort of speaks to these values was you can always hit undo. It's a complicated tool. There's a lot of like things you have to learn, and it can be intimidating in a certain way. And one of the ways you defuse the anxiety around a software tool or anything like that is you make sure people know that it has a way to be safe. And in this case, it has undo that works no matter what you want to do. And it also won't delete your data. That's an important thing. But it depends on the type of software, what qualities it needs in order to achieve that. And what comes out is, you see, and we would go do customer interviews, we'd actually chat with customers at conferences and say like, you know, get to see where they were, what they were struggling with, what they didn't like about the product, what they wanted it to do better. And it was really heartwarming to watch somebody who, once they got it, that they could just do whatever they wanted and nothing was going to be, like everybody's sometimes afraid, like editing documents in maybe Word or Excel, and like, oh, what if it like crashes and then I lose my work? And that anxiety means that they don't necessarily use everything that they could. Whereas with this tool, they'd be like, hey, I tried this, and then this, and this, and this, and they're like piling on all sorts of stuff. And it's super cool because they, like, if they had to code it themselves, they'd be at it for like maybe a couple days before they actually got a visualization or something, you know, because they were trying a new data visualization. Whereas here, they go click, 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 and then they're like, okay, well, that's a pretty good viz. How can I make that better? And then they try something else. I think I powered through that pretty fast. That's just a whirlwind. What do you guys want to hear about? What do you feel like? Yeah, I don't know. Yeah, any question? Sure.
Do you think it's ever possible that we're going to create nuclear power using nuclear fusion instead of fission?
Oh, do I think it's possible that we're going to create nuclear power via fusion versus fission, maybe?
Like I know
Yeah.
all of them use fission right now for all these reasons.
Yeah. Well, I would certainly like it. And I've been to the National Ignition Facility, by the way, which is really cool.
That place is really awesome. It's in Livermore. If you've not heard of it, you should definitely check it out.
Yeah, they do classroom tours, I believe.
The National Ignition Facility, I actually know a bunch of people who work there, so I can actually speak to this. They have the world's largest laser rays, so they've got a whole bunch of lasers, and then they shoot them at one time at really, really, really small things to try to create a miniature sun. That's basically what they're doing in like very simple terms.
And it does make a bunch of power.
And it makes a bunch of power, so it's basically trying to create a miniature sun so we can run things off of it instead of using nuclear reactors in a different way. But yeah, it's amazing lasers, it's huge, it's really cool. You can check it out online, they've got tours that you can do. And like I said, I know a lot of people who work there, and they're really awesome people, and they love having people come in and check it out. So it's definitely a really cool thing.
And I think it is viable. It's just a question of like, it's going to be very expensive. One nice thing is the nuclear waste is not an issue. So the nuclear waste with fusion is like, you know, you have these radioactive decayed heavy metals that have to get sent to Hanford or some other thing, and then you get into the politics of like, where do we put this thing? So fusion would be better, but it might cost $1 billion to $1 trillion for the first plant. And then
They've
Yeah.
done some proof of concepts
Yeah.
at the NIF, the National Innovation Facility. It's called the NIF by the people who work there. They've done some proof of concepts. They've gotten it to work in sort of moderated ways.
Yeah.
But yeah, I know cost is definitely a big thing that they're running into. And then also just making sure that they have, I guess, like the correct formula for their fuel.
A lot of it, I know a lot of it is like that facility is built as an experimental site. It's not built as a power plant. And building a power plant is different. Just like having a nuclear power plant is different from having a nuclear bomb in a way. I'm not saying it's a bomb. It's just so one of the main concerns is like, okay, you've generated, there's a ton of energy in this thing, it's coming out. How do you get that energy out? So it produces a ton of heat, and they spend a lot of time just recovering and soaking up the heat. In fission and traditional nuclear power, you're cycling water through it, and you're making steam out of the water, and then you're using temperature differences between hot and cold water, basically, to run turbines. And that whole process loses a lot of energy. It's basically just like a gas engine in a certain sense, but there's always going to be this waste heat that's coming off because you have to drive off the difference, not off the base. I don't want to get too deep, but I mean, the short answer is it's hard. I've looked forward to it, and I also look forward to, there's a bunch of nuclear startups now that make very, very small nuclear reactors with way lower risk, and that's a different debate, but I like the idea that it could be better, and people are working on it, so
Got a question
Yeah.
over here.
I don't know if this is something that you would work directly with, but
Okay.
we were talking about the nuclear plants and how like you need to do a lot of double checking when you're going through that different process.
yes.
Do you think that there's like room for the actual like design of the interface to like be more
Yes.
simple to make it for less room for?
That's a great question. Okay, so the question is, I mentioned double checking, and there's a lot of, I don't know how to summarize that question, but basically, do I think that the engineers and the designers could sort of basically plan for that and try to make it better? And the answer is yes, they have. So the early reactors in the 40s were just, they had maybe a few dials, they didn't know what to put in there. And a lot of the debate over things like 3 Mile Island and let's talk about Chernobyl is what were the operators presented with. And there's a field for this. I love this field. It's called cognitive ergonomics. The idea is like, how comfortable is your brain dealing with this situation? Are you overwhelmed with information? Do you have signals and like data visualization sometimes that help you figure out where to go and what to pay attention to versus what might be irrelevant? Yes. And then the question is, how is it getting applied? Well, it varies per field, right? There's different types of fields with different needs. And sometimes, like you think about, oh, a car owner, they're now presented with an electric vehicle which doesn't work the way that cars have worked for 100 years. What do they need to know? A lot of people debate about like, well, what's the range on an electric car? Well, with the battery, like if the battery's cold, you're going to have less range. And so you're talking about this chemical process and you're trying to use it in a percentage meter. And it's actually a little fuzzier than that. And so the question is like, well, how do you give them the idea that things are not as good as they could be and that's fixable or not? Yeah, and then you have highly technical people who work in software, who use things like the AWS console I saw somebody use earlier. And the AWS console is Amazon Web Services. Could be better. Could be better. Does not draw your attention to different parts. It has ways of making charts and graphs and things, but as far as like looking at the whole set of services and trying to figure out where to go, it's like, good luck. You know, you got to figure it out yourself. Yes.
So I know we have nuclear power submarines. Why don't we have nuclear power
Aircraft?
Yeah.
I have been to the. Why don't we have nuclear powered aircraft? That's a great question. That's actually one of those really cool questions. Or like, why don't I have a nuclear powered motorcycle?
Because I heard the Army, the U.S. and Russia were both working on this.
Yes, they were. So I have been to the Nuclear Aviation Office, which is closed. They do not do this now. They were trying to make strategic bombers during the Cold War that would be nuclear powered. And this is not unfortunately, this is probably a bad idea. So if you think about how dangerous it is to have nuclear power plants, if they're not operated perfectly well, right? And Fukushima showed the downsides when you have a reactor design that's maybe not the best, and it's presented with an earthquake and a tsunami. It starts to go south really fast. They could have done that way better. But once you put a nuclear reactor in the air, you have things like, well, the planes fall out of the sky for all sorts of reasons that have nothing to do with nuclear power. So what happens when you have a nuclear reactor that's plummeting towards Earth? Nothing good. I do know like all of the fail-safes around Navy reactors are all like pre-thought out. They make us like reason through it. There's things like, yeah, what happens if the ship sinks? There's all sorts of like, well, crush depth and blah blah blah, and it's like, and the reactor more or less is designed to kind of like collapse in on itself and like contain everything, like way down at the bottom of the sea. Or in shallower seas, there's easier ways, but yeah, and then with aircraft, it's just, so spacecraft are a little different because you can send out a spacecraft outside of Earth's orbit, you can send it off to other planets, and that's acceptable, as long as you don't have an accident on launch and you can plan around that. But aircraft, no, there's just too many ways for them to go badly, and then you've got a really, really dirty accident on your hands. To say nothing of the fact that, like, they pointed out that, like, the metal gets fatigued from the radiation. So neutrons, when they hit metals, they make them more brittle, and you just have to do all sorts of engineering around that. So, yeah.
What's your opinion on nuclear power not, like, being banned in space? Like,
what is my opinion on nuclear power being banned in space? So I think I kind of touched on that just now, but basically, in Earth orbit, it is a bad idea to have nuclear power. Anything that goes up will come down. Like, and even if it didn't come down, you have a radiation source on a piece of debris sitting up there forever. It's just too dangerous. When it falls, you have to control that fall. You have to put it somewhere, right? So that's really expensive. I think for interplanetary and interstellar kind of space travel, perfectly fine. No chance of it coming back to us, basically. But no, yeah, low Earth orbit, I can totally get. Yeah. Sorry.
What would happen if like a nuclear reactor exploded like in space?
Exactly. What would happen if a nuclear reactor exploded in space?
Do we know? Yeah.
Well, I mean, there's nothing to stop it, so it's an explosion that would just, get wider and wider and wider, and then there's the inverse square law of what happens to radiation as, it expands, it becomes more diffuse. So then the problem is, yeah, you have nuclear particles all over some area in space. And especially if it's in orbit, now you have an orbit with a cloud of stuff that's just moving around. That's the thing. We already have enough trouble with like space debris moving around at orbital speeds, so they have to check. There's like space orbit control. It's basically like checking like, okay, for everything going back to the 1950s, what's still up there and which direction is it going? Is there like a bolt that came off of a Sputnik? You kind of have to track it, because the bolt, when it hits something else in another orbit, it might hit it at like 17,000 miles an hour. So once you think about it being irradiated, then it could actually be like those whole uranium tank rounds that you used for a while that just basically melt the target. Because it's, let's stop thinking about that. Next, I think you had something?
One of the debates against nuclear power from some people is, other than the cost, of course, is the damage to the environment. So other than bioremediation, the other ways can we kind of address that?
I'm not an expert on this, so I've definitely reasoned about this, but I read more about it. So the question is, there's a good criticism of nuclear power as being hazardous for the environment. This has been a debate for, wow, so many decades. My position, I'm just going to put it like that, is it can be safe, it has to be operated well, there have to be plans around the whole life cycle, including the nuclear waste, which is something the US has just really not done a good job. Because we're not doing a good job with it, that's part of the reality of what we need to be. But it doesn't produce that many emissions, and if it's controlled right and the way that the like external water sources are managed and so forth, usually the only effect on the environment is a gradual warming of the waterways nearby, and then certain types of effects with like water evaporation. If you run a cooling tower, this might change how the marshland works nearby. Well, this is one reason why I'm encouraged by the idea of much smaller, easily replaceable, and much more isolated nuclear reactors that don't have these mega structures. I'm going to stop there. This is political. It is literally political for good reasons. Yes.
For like space colonization, would you encourage nuclear power to be used in like those sort of settings, or would you encourage it?
Would I encourage nuclear power to be used in space exploration? At the
For
moment,
space colonies, you're saying?
Yeah, space colonies
it depends on what we're talking about, and right now it's all a bit theoretical. Like if we're talking about Mars, I mean, I'm a save this planet kind of person. Like I definitely, it'd be nice if we could colonize, but like I really just like to prioritize fixing this planet before we go.
The easiest day on Mars would still be worse than the hardest day on Earth, probably.
I was going to say, well, one thing is like it's easier to colonize Antarctica than it is to colonize Mars, but we haven't done that, so yeah. I mean, there's nothing else has the energy, the punch, so to speak. Certainly, if you're talking about propulsion, and if we figure out fusion power for propulsion that isn't just dropping bombs in the back, that actually is actually pretty reasonable. And yes, there was a proposal that was basically we drop bombs out the back, and then we have this giant parabolic dish, and then the bomb reflects off the dish and pushes the spacecraft towards the star. That's a real thing, and I love studying that sort of thing. It's one of those, like if you look at the extremes of engineering, even the extreme engineering proposals, especially ones generated during the Cold War, which were crazy, it helps tell you, it helps, like, even an obviously bad idea helps you understand the space you operate in, which is way more like normal. Like you have to understand maybe what it's like to push something to the breaking point in order to understand how not to break it. So that's all I gotta say. Yeah. I mean, my day job isn't like this. I just have like a background. Anything else? Something I can get into? I like talking about troubleshooting more than nuclear power, I have to say. Yes?
So you mentioned that you were interested in like the mechanical aspect, then you shifted over to electricity and Navy, and now you're doing software. So how is it navigating between all those?
How is it now? I started, you're describing my background as like having started with aerospace mechanical, shifting into electrical, and then getting into software. And how is it navigating around all that? I guess I should be clear. The way I got started with all this was my parents had an Apple II, and I could program on it, and I started writing things like if there was a flight simulator on an Apple II, which is the granddaddy of Microsoft Flight Simulator, by the way. And I was like, I have to figure out how this works. There must be some way they made this happen. So and then I like made a little thing where I can, okay, the horizon's moving, fine, okay, how do I know where the aircraft goes and what is drag and, get on all that. With electricity, some of it's like if you have a mind for electricity, I don't want to say there's like a natural ability to do any of this stuff, but there's a certain type of reasoning that helps when you're working with electricity that that if you don't have it, you could be in trouble. So I think the thing was, I had worked that out already, and so they said, we'd rather have you do this job than the other job. I don't know how to put that better. I'm not a very good mechanic either. Often enough with electricity, people say things like, oh, it works like water flowing through pipes. And yes, that works up to a point. It's just that when a pipe bursts, you just have the water coming out that you put into it, whereas when a wire shorts, you have giant flashes and the metal melts, and I'll do the scare version of this, especially when I talk about conductors that are this big. Like, that's solid metal. It's not even strands of wire. It's a giant copper bar that's transmitting at 4,000 volts, maybe 2,000 amps, I think. I'd have to think about that. No, more than that. That's right, you can put more than that through. And those things can vaporize. And when you have vaporized metal, people die. Basically, you breathe in vaporized metal, and then you probably don't breathe very much. You will never encounter that. But that's the thing that made you scared to do your job as the electrician, especially when I see things like, now I knew I wasn't that far off, but like when you see the dimmer switch go off up in the aircraft carrier, like, this isn't normal. This is something I have to do something about now before it gets really bad. So working with electricity is hard, and anybody can do it, by the way. Anybody can do it, but you have to appreciate that things aren't going to work the way you think. Like you have to have this moment where you're like, my brain is meant to help me run, or it's meant to help me, you know, if you have mechanical sympathy, you can say like, oh yeah, the motor's struggling. But like when it comes to like shorts and grounds, you have to be able to kind of step back and say, okay, I'm not set up for this. How do I work through the, you know, the basics of like how to figure out what's going on and why. Yeah, I don't know how better way to put that.
Can we have your email in case students have other questions?
Sure. I'm Brian T. Rice at gmail.com.
You want to write it on the board?
Sure, yeah.
He also put up there the artofTroubleshooting.com, so if you want to check out that checklist, that will be really helpful for all of your projects. I guarantee that if you're trying to troubleshoot, that checklist will have ideas for you.
Yes.
And this is true of any project in life. So please do check that out.
It is a really awesome site. I remember when I
I'd also
figured
say
out
take down his email. So in college you can take Intro to Nuclear Engineering courses and Nuclear Engineering courses. However, you will see in your textbook almost twice per chapter that this section has been omitted because of confidentiality purposes. And this guy, he knows those answers.
Yeah, so I am trained to be, I know that I have found over time, I've found all the public domain materials that tell me things about my own job that I know I can share. That's how that goes. On occasion I see stuff online that's confidential and it hasn't been really marked that way, and I know where they are, and I don't know. It's not appropriate, and you're kind of like, and in a lot of sense it's over secretive, but it's
It's really cool. That's what
sure.
it means.
Yes. Yeah.
Awesome, thank you so much.
Thank you.
Alright, AM section, you are free to go. If you grab chairs from another room, please take them back to your original room.
I am not grabbing.
You're pretty much still